welcome everyone. Today it's my pleasure to introduce Fernando Alva Manchego, who is almost not a PhD student anymore at the University of Sheffield. Um, his work deals with text simplification, and I'm sure that he will tell us a lot more about this over the next hour. But yeah, let's go ahead and get started. Fernando, I will pass on to you now.
Okay. All looking good? Yes? Thumbs up? Cool, great. Okay, good afternoon, morning, evening to everyone, wherever you are in the world. First of all, just like to thank the NLP with Friends organizers for inviting me today to present some of my work on text simplification. And thank to all of you for coming and to listening to me for a little bit about this topic that it's not really talked about a lot, but it's a really interesting task, or at least I find it interesting, and I hope you find it interesting as well. So, as you said, today we'll talk about text simplification, and most specifically about evaluation, automatic evaluation of text simplification. So let's start with what is text simplification. Okay. The idea of text simplification is to modify the content and structure of a text so that it becomes easier to understand. But the changes that we make to make this possible need to preserve the main idea and as much as possible of the original meaning. So, for example, we have these two texts there, the original version and a possible simplification. And there are many changes that have been performed there. Let's take a look to some of them, okay? So we have something called elaboration, where unusual concepts are explained. Like in this case, they have added some examples for insects, such as crickets, reptiles, such as lizards, mammals, such as mice, rats, and rabbits. We have lexical paraphrasing, lexical simplification if you want, where uncommon words are replaced by simpler synonyms, such as comprising, by, there, or about. Sentence splitting, where a long sentence is divided into two or more shorter, easier ones. Like in this case, owls are the oldest forms comprising 200 birds of prey species, is divided into an owl is a bird, one sentence. There are about 200 kinds of owls, a second sentence. And then we have some compression as well, where information that could be considered unimportant is removed. Like in this case, though some species specialized in hunting fish. Now, you can argue that these are not the only operations that happen there, and I agree with that. So, for example, owls are the oldest forms was strongly rewritten into an owl is a bird. So there are many other operations, but these are just some of them. And the idea is to see that many types of changes can be performed in order to simplify a text. Now, depending on the operations that you perform, simplification has different scopes. You can do it just at the word level, which is also called lexical simplification. And you just only focused on lexical paraphrases. You just, for example, the cat sat on the mat, the cat perched on the mat. So you only change words, individual words or individual phrases, and that's it. You don't worry about the syntactic structure or anything other than that. When you go at the sentence level, you can have more variety of operations, lexical paraphrasing, splitting, deletion, etc. When you go at the document level, you increase the scope, of course, and now you see at the relationship between the sentences. For example, in this case, in the text on the left, the first sentence was split. However, when it goes to the right, the splitted sentences do not appear one next to the other, but a sentence that originally came below in the text was put in the middle. So there is a reordering between the sentences, which has to be done looking beyond the sentence level. So you have all these types of operations and interactions between the sentences. Now, in this talk, I'm going to be focusing on sentence level simplification. Why? One, because that's the main approach that it's being used right now, basically because of the data sets that we have available that are at the sentence level. So most of the resources and models are developed at this scope. Now, independently of how you implemented your simplification system, whether it is rule-based, whether it is using some neural model, a mixture of both, doesn't matter. You need to evaluate it in the end to see how well it does. Now, as in any other natural language generation problem or task, what you do is, okay, you have a evaluation data set that has, for example, some development data, some test data, which has the original sentences and some manual references. And you use that to generate an output from your simplification system. And then you compare that system output to the references using some metric, and you get a score. And if you have a high score, normally that means that it's really good. If you have a low score, it's really bad. And then you compare that score to the scores that other systems get. And then if you get a higher score, then your system is better than the other and stuff like that. So that's normally how it's done. So as we can see, there are two main components here. You have the evaluation data set with the references, and you have the metrics. Let's first take a look at the evaluation data sets and their characteristics and how they can help us or not to evaluate our models. Luckily, in the case of simplification, most of the evaluation data sets are multi-reference. Why is this important? Given a sentence, each person would simplify it in a different way. So it's a very personal decision of which operations to apply, how, in which order, etc. So for a given original sentence, there are many possible ways of simplifying it. So if you give the same original sentence to a system, there are many different ways that it can simplify it. So in order to be fair in the evaluation, the more references you have, the better, so you can find a reference that is closest to the system output. And that is a good practice that in simplification we have. Most of our evaluation data sets are multi-reference. The problem is that the most popular one, which is stored corpus, and another one derived from it, which is H-split, they both focused on one single operation. As I said before, there are many operations that you can perform, but they both focused on only one. In stored corpus, the manual references were produced by only using lexical paraphrasing. In H-split, the manual references were produced only sentence splitting, and that's it. So that's one limitation of those data sets that we have. Because as I said before, since human editors perform multiple operations at the same time, shouldn't we expect that automatic systems also do the same, perform multiple operations? And if that's the case, considering the characteristics of the data sets that we have, like stored corpus and H-split, are we really evaluating them for that multiple operation characteristic or not? So in order to tackle this problem, some collaborators and I created this new data set called ASSET, which we presented in ACL this year, and is publicly available in that link if you want to use it. Hope you do. So what is ASSET, and why do we think it helps a little bit with tackling the problem that I mentioned before? So ASSET is, as the other data sets, also a multi-reference evaluation data set for sentence simplification in English. Hashtag bend the rule. Human editors were instructed in this case to perform not just one operation, but 3 types of operations: lexical paraphrasing, compressions, and sentence splitting. We, of course, when we instructed them about these operations, we didn't tell them that they needed to use the 3 operations at the same time and in a mandatory way. We said them, these are the 3 operations that you could use. You decide which ones you want to use, in which order. So it was that was left to their own judgment. So, for example, we have this original sentence: he settled in London, devoting himself chiefly to practical teaching. The reference simplification, one of the simplification references that we have in asset for that sentence is he lived in London, he was a teacher. As you can see, the 3 operations were performed, some lexical paraphrasing, some deletion, there's a splitting. This is different compared to what happens for the same reference, for the same original sentence, intercorpus and H-split. As you can see, intercorpus, it's basically only lexical paraphrasing, and in H-split, it's only sentence splitting. The 3 data sets are aligned in the sense that it's the same set of original sentences, just the manual simplifications are different. Each set tackling different sets of operations. So that's also good. How did we collect asset? We use the magic of crowdsourcing, and we created a set of simplification instructions based on the instructions of the other data sets and included some of our own because of our particular needs. We performed some qualification tests in order to ensure that we selected workers that understood the instructions, knew how to simplify, and had the right English level. All the submissions to the qualification test were manually verified, and thus only selected workers were allowed to participate in the actual simplification task. We used, as I said, the same set of original sentences as intercorpus and H-split, so that they're all aligned. And we started to collect simplifications for all these sentences. We randomly sampled some of the simplifications submitted, so we can have some manual verification to see that simplifications were done properly, following instructions. These also allow us to adjust the simplification instructions and perform more qualification tests to ensure, again, quality. In the end, we collected 10 simplification references for each original sentence in both the dev set and test set. So there are around 2,359 sentences. So times 10 is the number of references that we have. So that's how we collected the data. Now, yes, we did some manual verification in the process to make sure that the simplifications were correct. However, how do we make sure that we obtain the actual goal that we had in mind, multi-operation simplifications that theoretically should be better than the single operation simplifications that we had before? So we evaluated the simplifications that we had in our data set in 3 criteria. First, the set of operations that were performed. Basically, did we succeed in collecting multi-operation simplifications? Then the quality of these multi-operation simplifications, in particular, whether humans prefer these simplifications where multiple operations were applied versus those where only one operation was applied. And then, since we're going to be using them for automatic evaluation, so we wanted to see how the metrics behave when using our simplifications as references. So let's take a look at the first one, which is, did we succeed in collecting multi-operation simplifications? So there are 3 operations that we're particularly interested in: lexical paraphrasing, compression, and sentence splitting. And we tried to measure them using some very simple heuristics, such as Levenshtein distance, replace only Levenshtein distance for lexical paraphrasing, the compression level for compression, and the number of sentence splits for sentence splitting. And we measured the density of these operations on all the instances in each data set. As we can see in all 3 features, asset offers more variability than H-split and intercorpus. In the case of lexical paraphrasing, we can see that H-split here has a very high density of no lexical paraphrasing, which goes in line with the instructions that the editors in H-split received about just splitting, no rewriting. While asset has more variability. In the case of compression, oops. In the case of compression, the same case. We perform more compression than the other data sets because, again, that operation was not particularly instructed for the other data sets. And in the case of sentence splitting, we offer more splitting instances than torque corpus, which has none. But of course, H-split, which was focused on sentence splitting, has more variability than us. So results are within expected margins. And we showed that, yes, we collected multi-operation simplification. So first characteristic, it's good. Now, how about the quality of these simplifications? Do humans prefer multi-operations over single operation simplifications? Basically, assets, simplifications in asset over those in torque corpus and H-split. So we needed to collect human judgments. And again, we used Amazon Mechanical Turk with a process very similar to the one before, using a qualification test and a set of instructions. And basically what we did was a preference task. So we showed the annotators one original sentence and two simplifications. One simplification was from asset and the other simplification was from either torque corpus or H-split. And we just asked them to say, okay, which one of the two is better, or if they are of similar quality. Which criteria we were measuring quality-wise, which sentence is more fluent, fluency, meaning preservation, and simplicity, of course. We did that for all the test set in asset, so 359 sentences for each aspect and for each data set. So all 359 sentences of asset versus torque corpus and asset versus H-split. What do the results show? Well, in general, when comparing asset against torque corpus, asset is better, it's preferred in terms of fluency, and most importantly, in terms of simplicity as well. When we compare asset to H-split, also happens in terms of fluency and simplicity as well, which could tell us that human judgments prefer simplifications where lexical paraphrasing was also performed, even though because H-split was only created using sentence splitting, even though it's an important operation, just by itself is not enough to make a sentence simple. Now, when it comes to meaning preservation, as we can see, torque corpus and H-split were preferred over asset in the majority of cases. What was that? Well, the existence of compression. Since we allowed compression to happen to delete some information, of course, some meaning is lost there. So, of course, torque corpus and H-split, where no compression was performed or very minimal compression was performed, are going to win in that criteria. However, there are also percentages of similar quality, which are also good indicators. So in general, simplifications in asset with multi-operation simplifications are very good and are better than the single ones in terms of simplicity, at least, compared to those in torque corpus H-split. So we have variety and we have good simplifications. Now, how does simplifications in asset behave when used to compute automatic evaluation metrics? So when you develop a metric and you want to know if that metric is good or not, what you normally do is, okay, you collect human judgments on some criteria, then you compute. So those are your manual scores. Then you compute automatic scores using your metric, and then you calculate the correlation between those manual scores and those automatic scores. If the correlation is high, then that means your metric is good in measuring that criteria, or at least that's more or less the idea. Okay. So if we wanted to test how metrics behave, we need to collect human judgments. So we collect the human judgments as well. Again, we use Mechanical Turk for this with the same quality control process as before to perform a rating task. Now, in order to collect ratings, instead of using Likert scales, we decided to use direct assessment, which is a methodology used in machine translation, which is commonly used in machine translation, and specifically on the WMT shared tasks for machine translation to compare the metrics and stuff. So what we did was we picked 100 original sentences from Asset, randomly selected, and 100 automatic simplifications from system outputs that are publicly available. And then we put them to the, we gave those to raters and we asked them to evaluate their quality using a continuous scale, which is what direct assessment does. So you use a continuous scale between 0 and 100. And you have to use that scale to show your level of agreement with some statements. What are these statements? If the simplified sentence is fluent, there are no grammatical errors. How much do you agree or not with that question? The same thing for meaning preservation and the same thing for simplicity. So we use that, and following the direct assessment methodology, we collected 15 ratings per each sentence, per each aspect, because that's the amount of ratings that you need according to the methodology to have reliable scores in the end. Once you have these ratings, those are your manual ratings. Then you compute automatic metrics, measure the Pearson correlation, and if it's good, good. If it's bad, it's bad. Okay, that's basically the idea. So which metrics did we evaluate? Blue, which is a metric that's been used in simplification for a long time and in a lot of NLG problems in general. Of course, blue has its own issues. We're not going to go there here, but it's popular, so we wanted to see how it behaves there. And SARI. SARI is a metric that was developed specifically for simplification. So, and it has been used in a lot of, it's used in all papers that publish related to simplification now. Now, let's take a look at blue first, okay? We calculated blue using references from Asset and reference for Tour Corpus. Why Tour Corpus? Because it's the data set that is currently mostly used for evaluation. We see that in terms of fluency and meaning preservation, the correlations are good, moderate to above moderate. But more importantly, in the case of simplicity, blue has a very low correlation, moderate to low correlation using Asset, and it's very low using Tour Corpus. Now, this goes in line with previous work, which has shown that blue is not a good measure for simplicity in general. So that's also good. But the issue here, or the most surprising results, comes for SARI. Yes, we knew that SARI was not developed to measure fluency nor to measure meaning, but it was developed specifically for simplicity. However, here the results show that when using Tour Corpus, the correlation is extremely low, and when using simplicity is almost moderate, but it's also low as well. But it's in general low. Now, why does this happen? Well, when SARI was developed, they measured it using only instances of simplification where lexical paraphrasing was the only operation performed, not when multiple operations had been performed. So this may tell us that SARI is not suitable to evaluate simplicity when multiple operations have been performed in the sentences. So you need to be very careful when you use that metric to measure the quality or the simplicity of your output, and just to use it when the simplifications were produced only lexical paraphrasing. In multiple operations, that shouldn't be used. And yeah, that's a word of caution, basically. So based on the previous results, if we know that multiple operation simplifications are better than single operation ones, but SARI doesn't really evaluate that, what happens is that we need better metrics. If the ideal is to have simplifications that perform multiple operations, we need a metric that's more reliable to measure that particular characteristic of the outputs. And we don't have that currently, unfortunately. So to summarize this first part, we created a new data set, which is called Asset. It's a multi-reference data set for simplifications in English, where the references were produced using multiple operations, such as lexical paraphrasing, compression, and splitting. Simplifications that are multi-operation are judged as simpler than those in other corpora, than those that are single operation only, specifically for simplicity. And when we use these multi-operation simplifications with our current evaluation metrics, they do not perform really well when it comes to measuring simplicity. So new metrics are required if we want to reach that ideal of producing simplifications that are multi-operation and that these operations and that this characteristic is properly measured, since SARI doesn't really measure that. So yeah, we have a new data set, but metrics are not that good. That brings us to the second part. So we already tackled the evaluation data sets. Now let's talk about the metrics and how those metrics behave. In the preliminary study that I showed before, we know that both Blue and SARI do not evaluate multi-operation simplifications well. Only those two were analyzed because those are the most popular ones in the area. However, could other existing metrics be used instead? And could they behave better? And in general, how reliable are the simplification specific metrics that we have? Now, as I said before, in order to measure the reliability of the metric, you calculate the correlation between the automatic scores and manual judgments. In the preliminary study, we collected new human judgments, but there are also some data sets with human judgments on simplicity that already exist with particular characteristics and limitations. And we could use them to measure the behavior of different metrics. So what are these data sets that already exist? So we have the simplicity gain data set, which was the one collected when SARI was introduced. And when SARI was said to be when SARI was introduced and was said to be the metric for simplification. Now, what is simplicity gain? Basically, the authors ask the judges in this case to count how many successful lexical or syntactic paraphrases occurred in the simplification. So it's a count metric. They're just count. The scores are not a judgment. It's just a count of something. Are discrete values. One problem is that this data set is very small. They only collected 93 sentences and simplifications from 4 systems that are very similar with each other. One is phrase-based, based on phrase-based machine translation models. The other one is syntax-based machine translation models. So in total, they only have 372 instances. So it's really small. And yet, with this small data set, they evaluated if SARI, the metric that we use now, is reliable or not. They also no report inter-annotator agreement, and the data that's public doesn't have enough information to calculate this score either. Now, if we look at the scores of this data set, we can see that the distribution of these scores goes between 0 and just 1.75. Remember that the score is a count of how many changes were made, how many successful changes were made. As we can see that not even 2 successful changes were made in the majority of cases. And the majority of cases actually is between 0 or less than 1 successful change. So that's not a very reliable data set. The data is too skewed into performing no changes at all. So this data set is small, it lacks variety as well of types of systems, and also the frequency of the operations is really skewed towards performing no changes. So should we use this data set in order to see if a metric is reliable or not? The other data set that exists is the structural simplicity data set. In this case, they try to only measure structural simplicity, which is considered, and they asked the following question: is the output simpler than the input, ignoring the complexity of words? And they use a 5-point Likert scale from -2 to +2 in order to get this score. So discrete scores, that's okay. They use 70 sentences simplified by 25 different systems, which are based on phrase-based machine translation, syntax-based machine translation, neural machine translation, and hybrids between semantic parsing plus some form of sequence-to-sequence model. Some form of sequence-to-sequence model. The inter-annotator agreement that they report is moderate, and that is in the figure we can see the distribution of the scores there. We can see that there is a high frequency of almost no improvements in structural simplicity, although there are scores for increased and even decreased structural simplicity. So there is some variety there. The problem with this data set is that it only focuses on structural changes. And as we saw in the previous part, structural changes by themselves are not judged as making a sentence simpler than incorporating lexical paraphrasing as well. So that's another limitation with this particular data set. So in order to overcome the limitations of these two data sets for measuring the reliability of metrics, we created a new data set, which is called the Simplicity DA data set. This is more or less an extension of the data set that we created as part of ASSET. Again, we collected simplicity judgments based on direct assessment, and as I described before, and we used 100 sentences that were simplified by 6 systems. The good thing about this is the systems that we selected are state-of-the-art neural models for sentence simplification. Of those familiar with sentence simplification literature, Access, DMAS, DCSS, DRESS, which are the state-of-the-art models, Access and DMAS DCS based on the transformer architecture are the ones that now the top models in the area. So we include them because we think it's important to include these more recent models into the evaluation. The inter-annotator agreement that we reached was 0.533, which is also moderate, but it's higher than the one in the structural simplicity. And this data set is bigger than the one of simplicity gain. So we have more instances, the outputs of neural models, and a higher inter-annotator agreement. So we believe that this data set for evaluating the reliability of metrics, it's better. And if we see the distribution of scores, we can see that they are equal, they are distributed across all possible values, which is also very good. So,
Fernando?
Yes.
I have 2 questions. One,
yes.
Why is there so many instances that get worse? Like,
sorry?
like below 0. Like there are many instances that get worse, right? Like below 0.
Yeah. Now, what happens in direct assessment?
Why is that?
That what happens in direct assessment is that the scores are standardized. So what happens is that for each instance, you collect 15 ratings, and then you standardize each of those individual ratings by the ratings of the same worker, so that you eliminate the biases of each worker. So when you normalize that, and then you average everything, then you can get both negatives and positive scores. In this case, even though the collected scores are from, the original collected scores are from 0 to 100, after they've been normalized, they don't necessarily fall just in the positive side.
I see. And another question, so the inter-annotator agreement is still relatively low. I wonder also why is that? Like, what are these hard cases which there's no agreement on, and why does this happen?
We didn't take a look at the actual disagreements, the particular disagreements, but it all comes from the. This is expected in simplification, because this is a very subjective judgment. What is simple for me and what is simple for another person is not exactly the same. Even though you have more or less the same instructions, it's a very subjective judgment. So that's where the agreement can be kind of low. In general, in NLG, inter-annotator agreement is a little bit low, and in simplification in general, we always expect not very high inter-annotator agreement. So yeah, it's mostly because of the subjective nature of what simple is.
So I have a question. So
Sure.
So do you expect also an expert? Oh, sorry.
yeah, go ahead, Yanai.
Sorry. So last question. Do you expect that also, like with experts, you would see the same agreement score? So for example, if the authors of this paper would annotate a few examples, you think that you'd see similar scores?
Yes, I don't even, with experts, you probably could have a little bit higher score, but I don't expect it to be 1 or super high, because it's still a very subjective nature. Now, that is one advantage of the simplicity gain way of measuring simplicity, because it's just a count. So a count is more objective compared to how simple it is, which is more subjective. So a count is more objective. However, as you can see in here, the data they collected is not really that varied. So, and we don't know the internal terror agreement there as well. So it's a little bit hard. So yeah, it's a subjective tax, so that's always going to happen there.
Thanks.
Was there any other question, I think?
Yes, so the minus in the Likert scale, when you're using, what was the question that was asked?
Here in the Likert scale.
Yeah.
In this case, it was, is the output simpler than the input, ignoring the complexity of the words? Now, in this case, what the authors used was -2 to +2. The idea was 0 if the sentences are exactly the same or not, or the changes didn't change simplicity at all. A positive score if the changes improve simplicity, and a negative score if the changes actually damaged the simplicity of the
Okay, I see. So the question actually doesn't reflect what you said.
This is a different data set, with a different question. And
if you go to the previous slide.
This one?
So the Likert slide. So the question that is quoted here, it doesn't, it's different from what you mentioned, because here the question is whether the output is simpler. It's a binary question.
Yeah, I mean, I'm just, in this case, my hope is that when the authors collected this data, they explained these details that they explained in the paper to the editors, to the judges, sorry, and that's how they interpreted. But at least that is how they explain in the paper that they interpret the negative to the positive scores.
Okay.
Yeah.
Thank you.
Sorry, I don't have a more convincing answer that that's what the author said that they did. But actually, when we looked more into this particular data set, we can see that there are some disagreements in the annotations and the data they collected. So you're very right in questioning, the question is not really clear and the score is really not reflecting what the question is saying, because when we looked and analyzed the data in this particular data set, we did find some spectacular disagreements there. So that's also one of the reasons why we decided to collect a new data set.
Okay, because Likert is usually the -2 is basically rejecting the statement, and the +2 is a strong reject to strong accept. So it depends on how you phrase the question. Yeah, okay, great, thank you.
That's okay. Okay, so yes, we collected this new data set, and then using this new data, we wanted to, check the metrics now. So we started to perform a meta-evaluation of evaluation metrics. I'm going to show here only the first part of this meta-evaluation because of course, time constraints as well. So yeah, and also because it's under submission somewhere. Now, what is the setting that we want to evaluate here? So we want to study the behavior of automatic metrics at the sentence level, not system level, sentence level. One, because of the data that we have, which is judgments at the sentence level for all of them. the size of the data that we have as well, and because we believe that it's more important for a metric to differentiate between the quality of two individual sentences rather than the complete system, which we know that can be affected by outliers as well. Now, we focused on metrics that measure some form of simplicity. So we're not taking into account fluency or meaning preservation, just simplicity. And we're going to analyze the variation of the correlations with respect to, just in this case, degrees of simplicity. We also analyze some other aspects, but I'm not going to be able to present that here today. Which metrics are we evaluating? BLEU, SARI, SAMHSA, Flash screen grade level, and BERT score, and also average of BLEU, SARI, and SAMHSA. BERT score, for those who are not familiar with it, is a metric that was recently introduced. Don't remember if it was this year or the end of last year. Basically, it computes the similarity between the system output and the references, and the similarity is computed using BERT context-based vectors, basically. Okay. All these metrics were computed using EASE, which is a Python toolkit that me and some other co-authors also implemented, that looks, whose aim is to standardize the evaluation of automatic text simplification with a standard implementation of metrics, standard data sets. So if you're working on simplification, we recommend using this tool so that results are more comparable across different papers. So if you use Sacre Blue, think of EASE as a Sacre Blue for simplification, more or less. So what are the results that we got so far? So what we did was basically, for each of the three data sets that we have, the simplicity gain, structural simplicity, and simplicity DA, we split each of them in two groups, low and high simplicity, according to the judgments that were collected, and we compute the Pearson correlation in each subset to see what happens. So first, simplicity DA, which is the new data set that we collected. Here we can see basically that there is a strong correlation for BERT score precision when all the instances are used. Flash-based metrics, as expected, they have a very low correlation. So if you still believe that Flash could be used for measuring simplicity at the sentence level, please don't. And then also very surprisingly, metrics that are focused on simplification, which are SARI and SAMHSA, also fare very poorly, which is a very interesting observation. Now, if we looked at the groups in general, not just metrics individually, but in general as low versus high, we can see that there is a decrease in the correlation compared to using all the instances. And we can see that low scores in the low subgroup, the correlation is higher than in the high subgroup. So basically, what is that telling us? That low scores of metrics, of some metrics, indicate the bad quality of the simplification in terms of simplicity DA. But high scores do not necessarily imply good quality. So this is actually surprising, because if you look at all the instances, which is the way that normally a metric is evaluated, you can have some conclusion. But if you do divide it into quality, you can actually see that there is a difference there. That metrics, in this case for simplification, are not really identifying good quality simplifications, but only saying, okay, if this is bad, it's bad. But if I'm saying it's good, this is not necessarily good. So the metrics are not very reliable in this case. So that's also bad. However, of all these metrics here, the best one seems to be BERT score. So, but what is BERT score actually doing? So BERT score, as I said, is measuring the quality, is measuring the similarity between the system output and the references. So for example, it's comparing the similarity of this system output against all these references, compares them individually, and returns the highest similarity between all of them. So in this case, returns a very high simplicity score, very high BERT score, very high BERT score, very high BERT score, but the simplicity DA scores are very different. So you should expect that this would be higher than this one, which is okay, good. And this should be much higher than this, should be also higher than this one, but BERT score does the other way around, or it gives the scores that are pretty close to each other. What happens is that in the references that we collected, we have references that have different levels of simplicity, which goes in line with the idea that what's simple for one person is not necessarily simple for the other person. It's a very subjective task. So some annotators, some editors, for example, thought that just making a small change to the sentence was enough. Some others might have suggested more operations. However, BERT score is going to return to you the one that has probably less changes. So there is a problem there of lack of information of the simplicity that the reference have, and also with what BERT score is measuring. So that's something related to simplicity DA. If we go to simplicity gain, which is what was used to introduce SARI as the de facto metric for simplification, we see that actually the correlation is very low. Now, the score that they report in the paper is actually low as well. So it's not that it's a problem with the way that R measure correlation versus the way that they measure. The value of the correlation is low as well. However, with simplicity gain, we can see that SARI has higher values than all of the other, including BERT score precision, which is the best one that we have for simplicity TA. So what's going on here? Well, the thing is that we have to come back to what simplicity gain is. Simplicity gain is lexical counting the changes that increased the simplicity. So in order to count a change, you need to compare the original sentence and the reference and to see, okay, this is a change and this is a change that improved simplicity. So you have to take into account not just the system output, but also the original sentence. And that's what SARI does. And that's what it probably has a better correlation than the other metrics that only take into account the system output. However, SARI is not perfect. SARI doesn't really identify replacements, which is the key operation for measuring lexical paraphrasing. So even though it's higher correlation, if we can see this here, we can see that simplicity gain here is higher than this one, yet the SARI score is low. It's the other way around, because basically SARI is not really identifying replacements. So also SARI is not reliable. What about the structural simplicity, which is the other data set that we had? In this case, we can see surprisingly again that blue is the one that has a higher correlation in all of this. And in this case, it's even higher when only using the high group. Now, this is surprising because theoretically, blue is not a good metric for measuring simplicity, yet here it seems that it works that way. However, when you look deeper into the data, that only happens in a particular subgroup of the data. That only happens in a particular subgroup of the data, and that's why this is happening here. But more analysis needs to be done there in order to actually understand what's going on here. Surprisingly, SAMSA, which is a metric that was specifically developed to measure structural simplicity, has a very low score. So again, SAMSA is also not reliable. So a summary of this second part, we developed a new data set for evaluation of automatic metrics following the direct assessment methodology. And we found that metrics can be probably more reliable to score low simplification, low quality simplifications in terms of simplicity DA, but this effect doesn't really happen in simplicity gain and structural simplicity. And more importantly, the metrics that we normally use in simplification, which are SARI and SAMSA, does not seem to be reliable for any of the quality that we're trying to measure. So more or less the same conclusion in the first part. We need better metrics. So if you're into developing metrics and evaluation, please help us in simplification to develop better metrics for our case. So with that, I'll finish. I think we have still some time for questions if there are any. So thank you very much.